The primary thing about Retcon is for people who rewrite history often or who don't rewrite history because they think it's too slow. It allows you to do it like instantly, as fast as it could probably be in terms of interaction.
Hello, welcome to the devtools-fm podcast. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey, everyone. We're excited to have Nathan Manceaux-Panot on. I hope I got your last name right. So you are working on this tool called Retcon. It is a tool to help rewrite Git history. For probably everybody listening to this has used Git or probably uses it on a daily basis. And I'm really excited to see what you're doing and talk about like why you've done it and everything. But before we dive into Retcon, would you like to tell our listeners any more about yourself?
Sure. So I've been a developer for a while now, but the fun thing is I was in front-end development for the most of my career. That's what I fell into as a teen, and that was most of my career. But a couple years ago, a bit more than a couple of years ago, I left my job and had some time and thought, hey, I'm going to try and work on that side project, right? That thing I had, that idea I had, like I had a bunch of notes, a bunch of little outlines, drawings of interface in a notebook somewhere, and thought, hey, I'm going to try and take a couple of months to work on that. And this is how I get started working on Retcon, which is like a macOS app. So absolutely nothing to do with from the developer.
Was it your first go at like Mac development? Because I noticed it's like a Swift app, it looks like, or at least Swift or Objective-C.
Yeah, so Swift, absolutely, and AppKit. So Apple's older UI framework, but I think it's still the right choice today for some Mac apps, such as Retcon. And yeah, that was my first Mac app, which is fun to say because when your first, app in anything is a Git client, like that's a terrible choice as a starter. But here we are. But before that, I did have did work for a few months on the iOS stuff, like learning iOS stuff. Stanford University actually has these free video courses online, like on YouTube, I think, by Paul Haggerty, and they're excellent. Like if someone wants to learn iOS development, they're really good. Like the teacher is really good. And so that's how I learned iOS development, and a lot of that transfers to macOS development.
You said building a Git client's hard. Why is it hard?
Yeah, on the surface, I don't know. On the surface, what's Git, right? It's just a bunch of commits, and they contain code changes. Obviously, I didn't write it from scratch, right? I'm using a framework, libgit 2, which gives you all the basics. Basics, like if it's underselling it massively, right? It gives you commits and branches, exploring, and diffs. You can do rebases, all the core functionality of Git is there. So, if you wanted to write a basic Git client, like a general Git client, a regular Git client, the hard part would be the UI. It would really be like, how do I display that stuff? Because actually, even just displaying information in Git is just terrifyingly complex. Displaying a diff, if you do it very simplistically, it might be okay. But as soon as you want to interact with it, users to interact with it, it's super complicated. So, the first hard part of building a client is the UI. There's so much surface, so many things to see, to show, and so many concepts in Git. Like at its heart is just a list of commits, but they're on different branches. They can have tags. When you create a branch, there's a million things that can happen. Not a million things, but you can create the branch here on a different commit. And maybe you're trying to use a name that's invalid, or it's a valid name, but it's the name of an already existing branch. So all that, when you're building a UI, you're going to want to take into account. It's a massive pile of complexity, but like complexity by breadth, I would say. For a regular Git client, the complexity I think is not in the depth. Like you don't have to do anything crazy complicated, but you have to do a lot of it to get something basic. And so that when you're only trying to display information in a Git client that follows the conventions of Git, but then if you want to go deeper and make something like Retcon, which goes crazy with what it does with a repo, then you have to get into that complexity. And I guess we can talk about that more in depth later, but it's just, you're going to handle diffs and, I don't know, commits and orders. And I mean, everything can happen at that point. Yeah.
So maybe let's back up a little bit and talk about Retcon specifically. So what is it and how does it differ from like a typical Git GUI app?
Right. So The focus in Retcon is very different. Initially, I thought it would not even do all the basic functionalities of a Git client, like, well, to give you an example, I think when I added pushing pulling, like from remotes in Retcon, it had been in existence for more than 2 years. And creating commits, like committing, that was added after at least 9 months, I think like 12 months or something. So that gives you an idea. Like Retcon focuses on other things, and nowadays it does have these basic features, managing branches, etc., for the most part. But the very core of Retcon, what makes it valuable and unique, is its ability to rewrite history, but like to let you rewrite history much faster in a very different way. So it's about interactive rebases. So I'm going to describe them quickly for anyone who is not so familiar with them. So typical workflow in Git is you do some work and you commit it. So you embed it in the commit is the message, and your changes are encapsulated in there. So you do commit after commit. In some teams, you're going to want to rewrite history from time to time. So you're going to say, hey, I created a commit that's called fix bug and another commit that's called add feature. And these are not very good, right? This is not very clear. So maybe I'm going to want to rename that commit or reorder them, or maybe even merge commits together, fix up them or scratch them. So that's rewriting history, taking your list of commits and rearranging it in a way that makes more sense. It's super useful because you can get... super useful for many reasons. It's an act of communication, right? The commits always contain the code changes, but not always the intent. And having a clean history, right, well ordered with clean messages, that tells you why you made the changes, that recapture the context around them, which is useful for if you have colleagues reviewing your PRs. They can do it much more quickly and nicely if they know what it's about, and your history can just tell them. And it's useful for you in the future when you come back to these commits and try to understand what the heck you were thinking. Like, why is that class? Why did it even add that thing? Why did it add all that complexity? That's the kind of questions that having a clean history can answer. So Retcon is focused on that. And the way you would typically do an interactive rebase is using the terminal, right? So you would do a git rebase interactive -I. And the way these go is you initiate the rebase. It gives you a to-do list. So it gives you the list of commits, like the current state they are in right now, and you modify that list. You reorder the lines, because it's just a text file. You do whatever you want. Reorder the lines. You can add a special marker at the beginning of the line. Just, hey, I'd like to reword that commit to fuse it, like fix up with merge it with a parent commit. So you do that to-do list in there. And when it's done, when you close that window, the actual rebase happens. Like it tries to apply your to-do list. And that may succeed, or you may encounter conflicts. That's a lot of exposition. So you may encounter conflicts. Like if you delete a commit and it changed some lines and a later commit changes the same lines, Git doesn't know what to do. So it pauses for conflict resolution. And maybe you want to resolve multiple conflicts in a row. And when that's done, the rebase is applied. So that's the basic way it goes. You can do that in the terminal. Some Git clients, GUIs, will allow you to do the same thing visually, but it's very much the same workflow. Create a to-do list, and then resolve conflicts one by one, and then you're done. Retcon was born of the idea that, I love rewriting history. I think it's super valuable, but also ain't nobody got time for that. And seriously, the concept is elegant. The UI, honestly, is pretty good idea, but yeah, it takes so long. And even for the smallest modification, like if you just want to rewrite a message for a commit that you made a while ago, it's like you have to go through all these steps. So it's a huge chore. Retcon focuses on making all these actions available immediately. So if you want to change just the message of a commit, you go to your list. So in Retcon, you always see the list of commits. You select an old commit, and where you see this message, you type the new message, and that's it. You don't even have to confirm. Like as you focus out the field, it saves it in place. So there's no step 2. There's barely a step 1 in that case. You just find the commit, change this message, and it's changed. Like renaming a file in the file explorer or something. Or for a more complex example, like you just want to reorder things. Well, you have this big commit list, and you just click and drag. Like you move the commit from where it is to where you want it to be, and that's it. That is it. Someone actually commented on Mastodon, I think. They said, hey, I was confused for a while. I was looking for step 2. They were looking for what to do after moving the commit. They were confused because, yeah, that's what we would expect. But no, in Retcon, there's no second step because there's no mode. You don't have a to-do list, then an application of things, then you're done. No. It's always the same thing. You're always in edit mode. And so that's really the primary thing about Retcon. It's for people who rewrite history often or who don't rewrite history because they think it's too slow. It allows you to do it like instantly, like as fast as it could probably be in terms of interaction.
We'd like to stop and thank our sponsor for the week, Mux. If you've ever tried to add video to your product, you'll know that it's full of pitfalls. Whether it's hosting, streaming, or even building a snazzy player, there's a lot of things that you have to get right to deliver a good experience. That's where Mux comes in. Mux offers an end-to-end set of tools that let you ship video to production faster than you've ever been able to before. The feature I'd like to highlight this week is their automatic cold storage feature. With video, the highest operational cost is hosting all of those videos. It can be a lot. With Mux's automatic cold storage feature, it makes it a bit cheaper. For each video that your platform has, it tracks whether or not it's being streamed. If it hasn't been streamed in a certain amount of time, it moves to colder and colder storage and saves you more and more money. I think that's pretty cool. That is just among a host of other things that make shipping video with Mux a breeze. So if you want to learn more about Mux, head over to mux.com to check them out. So to accomplish all of that, are you like stashing and popping things in the background, like to like abstract away stuff, or like how does that work?
There's a lot of stashing, reapplying, and rebasing in the background to abstract away stuff. Like that's actually a good description of what's going on. And there's multiple layers to it, but all right, at the core, there's the idea that if you do edits in place natively, you're going to run into trouble. Like in my example, right? You move a commit to a new place and that's applied instantly. That sounds good, right? And I thought, let me just code that up. But you'll quickly discover that it may cause a conflict. I mean, of course, but what do you do then? Because when you have a conflict, in regular Git, you can't do anything. You have to resolve it now or cancel everything. But for Retcon to be useful, that can't be the case. If when there's a conflict you're stuck, then there's a lot of things you can't do because you move the first commit and you're blocked and you're like, oh yeah, but I want to make more moves. It's not, whereas in the to-do list from the regular mode, like from the regular Git, the to-do list, you can do anything you want and then you apply it. So if you need to make multiple moves, you do that. In Retcon, you don't have the luxury of saying, oh yeah, well, we'll see later. Not in that technical way. So the core thing about Retcon is that it still allows you to make changes when you have conflict going on, when it's paused. I call that state being paused. So you move a commit because it is a conflict, and you're like, whatever. You move another commit and another one. Maybe you delete a commit, you can rename. Above and below, by the way, the conflict, like above the conflict, below the conflict, you can do all the changes you want. And then when you're done, when you're satisfied with how it looks, at that point, you start resolving conflicts. Although sometimes making another move will remove the conflict. Like you move one into position, there's a conflict. You move a second one that clears the conflict. You didn't even have to resolve that. So that's necessary. Like what I've just described, that's just user interaction, right? That's just how you see it. You're like, oh, I can move things even when there's a conflict. But then there's, okay, how do you achieve that technically? Like how in Retcon was that coded? And the idea is that Retcon needs its own in-memory representation of your history. I call that virtualization. That's a bit like React's virtual DOM. That's very similar conceptually. So there's the virtual history in Retcon. There's an internal data structure that's really close to just being an array. That's virtual history. And so anything you do in Retcon, it modifies that virtual history. So you move so whenever you do anything, it modifies that intermediate trend representation in Retcon's memory, and then it tries to apply it to your actual physical repo. So if you move a commit, Retcon will be like, okay, here's a new virtual history, like it's kind of immutable in place, sort of functional. So it's like, all right, it makes a copy of your current history, modifies it with that move you've made, and then it tries to realize it, to make it physical, to see, okay, can I actually make a history like that? So Retcon will ask Git, like it's a series of cherry picks, basically, and to recreate the new history. And maybe they'll succeed, and maybe they'll fail with the conflict. If it succeeds, well, very cool. Like it's got a new head commit, so it applies that and modifies your branch. It applies your your virtual history. It's physical now. And you didn't see anything, right? You moved it like it's instant. It's not something you perceive. Or if there's a conflict, well, then it pauses. So it shows you, and that's the fun part. If there's a conflict, Retcon's going to show you your history, like your target history, which you made. So the reordered one, which doesn't exist, it only exists in Retcon's mind, is the virtual history. But it'll be displayed exactly like your normal physical history. And it'll rewind time. It'll check out the conflicting commit and allow you to resolve it if you want, like a normal conflict resolution. It checks it out, it preps everything for resolution. So that's the core thing, right? Anything you do, it's applied to the virtual history, and then that may result in a valid history or not. If it's valid, it's applied. If it's not, you're in that overlay mode. You're paused. And when you're paused, you can keep making changes, and that's perfectly natural for Retcon because you're making changes to that virtual history. You keep modifying it. That's just, once again, sort of a big array in memory of commits. And whenever you make a change there, Retcon checks, is that valid? Can I apply that to the physical repo? If so, you're out. If not, you're still paused, and maybe you're paused in a different spot. And that's really like a huge part of what makes Retcon, both what makes it complicated to work on and what makes it a good tool is really this virtualization concept, and the idea that Retcon is able to represent histories that do not exist, that are not valid by Git standards, and that everything in Retcon, every single feature, is built on top of the virtualized history. So yeah, wherever you're looking, whatever you do in Retcon can happen regardless of virtual states, basically. So you can even rebase, for instance, while pause for conflict resolution. You can actually push from a remote. Pull. You can pull from a remote while pause for conflict resolution. Like you're in the middle of a rebase and you realize, oh no, I'm missing that one commit, and this is the reason for the conflict. You can still pull, and it pulls, and it rebases on top, and that works because everything's implemented on top of that virtual history concept.
That's really wild. It's such a cool approach. This is like an event source an event sourcing system for your Git history, kind of. I was trying to think of like the implications of that, and one of my immediate questions was like, well, what if you muck around in the thing while it's paused? So it's really interesting to hear that it'll like pick up those actions and sort of like, insert them in the correct place. Is there a point at which you just have to throw away the virtual history? You're like, okay, you've done something and like we're down this track, but like we just need to like abort and go back to like the current state of the repo, or like unwind the virtual history stack or something?
I don't think so. I mean, anything. No, because like you transform the virtual history and it always represents something. I mean, if you, like in the most extreme of cases, you'll get conflicts at every commit, right? You resolve one and the next one's a conflict. But you resolve all of these in a way that makes sense if you can, and at the end you get an actual history that gets physicalized. Another extreme case would be deleting all the commits. I think that works, and that just deletes the branch. I mean, gotta do something, so it doesn't make much sense, but you can do like Command A and delete it. I'll just delete the branch. Why not? And you make that comparison to an event source, and that's the initial approach I had was this, and this is why I used the word functional before. Initially, it was not in that functional idea. It was like a series of transforms. That was my approach initially. Anything you do, where I can remember, is just like, okay, from the initial physical history, you added this, renamed that, etc. But it turns out that was not as resilient. That was harder to code with. And so the idea now is that it really creates a copy of your history. Of course, there's a lot of copy and write stuff and all that. It's nothing crazy, but it's sufficient in memory. But the idea is that you just represent your history as you want it to be. A list of commits that can have virtual transformations attached, like rewording and all. It doesn't actually do them instantly. But mostly it's kind of stateless. It just represents the state you would like to get to. And anything, and so the key also is that anything you do in Retcon, it always gets applied to that virtual history. So in a way, there's no difference from going to a valid history, like you're currently unpaused, and you make a simple change, like you reword, Like that is the exact same thing as being knee deep into a rebase where you have 3 conflicts resolved and 3 pending, and you rename a commit at that point. It's the same thing. All you're doing is taking a virtual history, changing a little thing in it, and you get a new one. It's just that in one case, the virtual history is like instantly generated from your actual physical history, and in the other case, it was in memory already because you were paused with that virtual history.
I imagine there was a lot of crazy bugs to figure out in that, because just synchronizing states is one of the hardest things. I think one of the hardest things in computer science. It's like, just years of dealing with like, oh, you have like a server in this state and a client in this state. You need them to like be sort of have the same representation. This is like how many like millions of man hours have we spent just trying to, work through sync issues.
Yeah, I don't know how to frame this exactly, but yeah, bugs for sure, a bazillion of them. Actually, a very scary one. If anyone's thinking of actually using Retcon, please use Retcon. It's good. But it was really early on. The thing was weeks old, and it just wiped the entirety of a repo. Like a friend was trying it at work, by the way, right? Work repo. He had a lot of faith in me. I appreciate him, and it just deleted every single file in there. That was more than 2 years ago. I have a battery of crazy tests now. The tests just go through everything, like every scenario you could think of, and well, I mean, there's so many things about this, but like they test undo redo. So anything, they'll do like, oh, what if you modify this and edit this and delete that file and then confirm, and then you undo all the way to the beginning, and at every undo step, the tests will check that we rerun the asserts from that step. So we know that at every step, it's exactly how we expect. And then they redo everything back to the end and rerun every single assert along the way. So yeah, like there's a crazy amount of tests. I have so many safety features that I've built up over the years. So some of them are for development time only. So some of them run at runtime. And actually, in that scary story I just told, at the time there was a whole repository backup feature. Like it would just back up everything, even the ignored files, every 15 minutes in a hidden folder, so that if something happened, you could recover. Because at the time, I knew it was very new and wild, and that was a risk at the time. So I had these things. So yeah, bugs galore. Yeah, and at the same time, there's something reassuring about it, because you do talk about sync, and yes, but also no. Very, very, very eloquent. The idea is that, well, it's back to that functional approach. You don't want to have to keep track of small changes and everything, and deltas and stuff you need to do. And it's more about absolutes. You want to know what you want to get to, where you want to be. So, in memory, what is stored is the virtual history, like the absolute thing you want to happen. And that moves the problem. That doesn't remove it, that moves it. It means now the problem is having a correct absolute thing at all times. But that also means it can be handled differently. And so, like I just talked about undo, and that's an essential thing in Retcon. Like if you have the ability to just change everything, anything with just a click and drag, you definitely need the ability to undo it just as easily. Like it's non-negotiable. So yeah, undo, redo in Retcon, and it's pervasive. So almost anything you can do in Retcon, you can undo. So like deleting a commit, moving a commit, rewarding, but also like deleting a branch or pushing to a remote. That one's a bit special, but even pushing to remote, you can safely undo. Like you won't override anything by mistake. That. And so the way I had to go to implement that, initially I thought, I'm just going to record the state of things whenever, like before the operation. So I was like, all right, to implement undo, I'll just make a big snapshot of everything before the operation and then record that data somewhere, and that's my undo stack. And when you undo, you go back. But then no, that's much too naive because of a bazillion reasons. The biggest reason is Retcon often doesn't touch your uncommitted changes. Like you can safely do all you do in Retcon, even when there are unmodified files in your work there. And like 10 things to say about that again, but yeah, that's the core thing. And that includes doing things like, all right, you have a commit, and it modifies some lines in a.txt. Well, it adds a few lines, it appends a few lines to a.txt. You delete that commit. So the lines, they go away. That makes sense. You go to your editor and you change that same file. Like in the middle, you change a few things. And finally, you go back to Retcon and you undo that. You undo that commit deletion. So you're undoing a deletion, so that's going to add some lines to a file that you've modified. That works. That works exactly as expected. The files, they come back, the commit comes back, lines come back, and your changes in the middle of the file, they're preserved, like untouched. You don't see the difference. You forgot about them. And, probably most people won't think about it when it happens. They'll be like, yeah, I did the commit deletion. That makes sense. But in practice, that means Retcon needs to rebase a bunch of things. It needs to take your changes and rebase them from the old head to the new head. So it's like a relative thing. It couldn't store the absolute contents of the file before the undo, because if it did that, it would override your changes. So instead, it's constantly storing things in an absolute form, but also reapplying them relatively to whatever's going on right now, because it's very delicate in that way. It's absolute in its storage, but delicate in its actions, always trying to change the minimal amount of things it can so that whatever you did is still there and preserved.
So we were just talking about undo there. Is there redo? And then also, I feel like you could undo back to a place, accidentally edit a file, and then try to redo. So how does it like deal with interim changes like that? Because I could very well imagine like work just getting blasted away as I'm like going forward and backward.
Yeah, I don't think there's no satisfying answer to this, because you can undo, you can redo, but it has the same limitations as in like a word processor or like in an IDE, that if you undo and make a change in Retcon, well, that will replace your redo stack because you've made a change, so that all the redos are gone. So definitely in that way, it's just that, right? Undo redo works just in a regular app, but I don't expect people to undo really far and expecting to come back. Like that works, right? If you undo 100 times, you can. I think it's just limited by memory, basically. But you can undo 100 times and you'll get exactly where you were before. And then you can redo 100 times and you'll get exactly where you were there. What will prevent you from redoing will be if you make any change in Retcon, or if you change the history or the stage from another app, because these things also get added to Retcon's undo stack. So you can actually do something in Git in the command line, and you can mostly undo it in Retcon, with limitations because it doesn't know exactly the context of the change. So it can't guess at what happens, but it can definitely undo branch changes and stage changes. So it's like, and this is interesting because it's like, this is more of a design thing now, but it's both a strength and a limitation of Retcon, that it works, like its undo works just like the undo in any GUI app, right? Undo redo stack.
Mhm.
So that means it's incredibly intuitive. There's like a chart on my website. It's like, how do you undo this thing, right? And for every single thing, it's like press Command Z, like every single thing, press Command Z. You already know how to undo in Retcon. That's a strength. The weakness with that is that it has the same limitations. So if you make a change, if you undo 5 times and change something, you can't redo anymore because you've just created a new undo point. And this is something I'm thinking of changing, but I really don't know how. In terms of design, once again, it's the branch push thing. Like if you push your branch, well, you can undo it very easily. Command Z works super well every time. Spent a lot of time working on that thing, but you can only undo that. Like you can't undo a local change like reordering commit. First, you have to undo the branch push because it comes in that order in the undo stack. And that makes sense, right? The undo stack works the way it does, and this is what makes it intuitive, but also it's at times limiting. You're like, okay, I'd like to undo my change, but not undo my push. And I had this situation the other day, and it would deploy on Netlify, like, because I use Netlify, so any change I make instantly deployed on a distant branch, and I had to undo that push if I want to undo the rest. So pluses, minuses.
Yeah, history undo is pretty challenging, I think, in general, because there's a bunch of different strategies. You can have just like a straight undo stack, or you can have like a branching undo model where like you have like different forks that you can take, and not to be confused with Git branching and Git forking. I mean, all that makes sense. I was reading through the landing page though, and one of the lines that you wrote that I really like is the cheat sheet you won't need. Just talking about undo is like, oh, you did a thing. Command Z, you're out of the thing now. That is huge. That is massive. I think sometimes with Git in particular, and a lot of the tools that we use, we kind of have this Stockholm syndrome. It's like we like come to love the things, but it's like, maybe not always. It's like through a lot of pain. So given your now deep expertise and like digging into Git's internals, or at least like the interfaces, the programmatic interfaces that Git's providing, what are some things that you wish that Git did differently that would make your life easier and or other people's lives easier? Like, if you could make a change to Git today, it's like, okay, well, if I did this, it would make things so much easier. Like, what would that be, and why would you want to do it?
That's a good question. I don't know that I have an answer for that. I'm thinking because a lot of, I don't know, Git is pretty tight, right? Like the model is pretty solid. I'm going to avoid that. I'm gonna evade that question and go slightly to the design side. I think something in Git that's made my life really hard is the terminology. It is so bad, so bad. And no offense to the people who came up with it, like it's extremely hard to come up with good terminology. And when you do it like over, I don't know, 5-10 years, like how long the core terminology of Git came along. And like, anyway, no offense, right? I appreciate how hard it is. But stuff like, okay, the stage, that's also called the index and also called the cache. And like all of these three words, they're synonyms, but also some things have these names and others don't. Like an index is a data structure type, actually. And the cache is just using an index as its data structure to back it. And it's a mess. So yeah, the names in Git. And what made things even harder is that then for Retcon, I had to come up with new terminology for some of the things, like, oh, you're paused in the past. A lot of words, new words need to be used, and I would constantly be how to say this, split between using familiar Git words and using more descriptive, potentially better words. And this is a big dichotomy at the heart of Retcon, is that it targets both experienced users and beginners. Like, I built it for myself, so like I know what a Git relays is, interactive. I know how to do them. I'm comfortable with them. But I built it because I wanted to go faster. So in that way, it's squarely targeted towards experienced people experienced with Git. Right, like it's not a good GUI to make it easier, but it's not that powerful. No, it's like for going super fast. At the same time, it is a GUI, and I did try my best to make it like super approachable, because it can. It had the potential, so I worked really hard to make it newbie friendly. I think it mostly does the job on that. And so what that means in practice is that for every piece of text in Retcon, I always thought, okay, I can come up with like a better word for this for sure. That'll better describe what the thing is. But if I do that, people who know Git, they will have no idea what it is, and they will assume it's a whole new thing because it's a whole new word. So it follows that it should be a different thing. And there was such a thing, like for fix-ups. You can fix up in Retcon, which is like a squash, but you don't keep the message. So most people know squash by name, but fix-up is the thing you often want to do, because if you had a temporary commit, you don't care about this message. And none of these words is descriptive. I mean, squash may be okay, but that's not what Retcon does, so that would be misleading. Fix up, no one knows what fix up means. So it's like, do I call that merge? Oh, no, I can't. Merge means something in Git. Do I call that flatten? That's weird. It was the case for a while. It said flatten there. And like, yeah, there's that thing went through many iterations, and now it's fixed up. Because I'm like, okay, if I can't find a great word, might as well use the one that some people will know already. And same thing for, that was a big challenge, deleting commits. So in Retcon, you can delete commits. You can do a hard reset or a soft reset. So you can delete a commit and discard the changes it contains, or just delete the commit but keep the changes it contains. And that took so long to find the right terminology for this, like the menu names. And in the end, I went with something very descriptive, like delete commit, and the other one is delete commit and keep changes or discard changes. Anyway, there's a so you see them by one side by side, and you kind of understand what they means in this way. But it took a while to get there because yeah, delete commit, delete changes, delete commit and changes, only delete commits was like only. What do you mean only? Just yeah. So that's yeah. I think one of the hardest part of building a Git client was that finding the right terminology that would respect the existing one, but also could extend it and be very concise and be less confusing. was a that was a trip.
Yeah, when I was learning about Git, I was surprised to learn about its origins, that it didn't start as what we all know as a version control system, and it was more of like this weird database of things. And then what we have as Git today kind of emerged from that. So lots of complexity hidden there for sure. So going back to Retcon a little bit,
Sure.
to me, it seems like you're tackling UX challenges in Git that you want to fix, whether it's rewriting history, Command Z. Are there other things that you want to fix with Git that you think have less than stellar UX?
Oh, good question again. I've been deep in the trenches lately, so I'm more focused on what I've worked on already. But yeah, there's a bazillion things. The core Git model is really nice. Like the concepts are, it's really well thought out. But yeah, there's so much to change. Well, there's one thing, and okay, this is one thing that is changing in Redcon. And that I haven't gotten a lot of feedback on, so I should ask for that feedback. It's got to do with the stage, the way you stage things. So in usually in Git clients, when you want to create a new commit, you're gonna go and stage things. So you've made changes, your working directory, it's dirty, right? It's got this uncommitted changes, and you're gonna stage some of them. Like, oh, that file and this file, I want these to be contained in the commit, but that third file doesn't come along. So you stage just what you want. It's at file level, and it's also at line level within the file. The way these are displayed in most Git GUIs, and I think the Git CLI sort of funnels you also in that representation, is that it shows your uncommitted changes separate from your uncommitted changes that are staged. Like these are really two different boxes. So you'll have work dir and stage, usually, these two things. And now I know why, because I for a long time I was wondering why would they separate them? Because the intuitive thing would be to me anyway, would be to have a single view. Here are all your changes, like from the current commit, from the latest commit, all the changes you haven't committed, and some of them are staged. But no, in most clients, you have these two boxes, and that causes issue. Like when you stage something, it disappears because it goes to the other box, it goes to the other section. And if you're like, oh shoot, I staged something I didn't want to, you have to go to that other box and unstage it from there, and it disappears again. You don't have a bird's eye view of everything that's going on. And that is something that bothered me for a while, especially since some apps already do better, already have this checkbox concept, but usually only at the file level. And I think that's super useful because you see the list of your files and you're like, this one, like you check them, they're checked. And that's it, they didn't move to a separate location. So in Retcon, this is actually different. It's a single view and you can just check stuff. And when you see the file contents, you can also just check lines in there. You have 3 changed lines, you can just check the second one, and then now it's staged, like it's a little check next to it, and that's it. And I'm coming up like I'm having a hard time describing what happens because it's so simple. Like visually, you're like, yeah, I checked it, now it's checked. But the thing is, it is monstrously complex, monstrously complicated to actually implement that. And I was not prepared for this. I was not ready. This took month and month of work to actually implement. Because the way Git works, it actually provides you with these 2 diffs. Like you can ask it for 2 diffs, head commit to stage and stage to work dir. You can't ask it for like the combined diff. You have to make it yourself. And so that's what happens in Retcon. So it's like a whole bunch of steps. So Retcon collects these 2 diffs, like ask for these 2 diffs, they're generated by Git. So it's just a long text thing, right? Like a long piece of text of every line with metadata for each line. So it's like, oh, here's the old line number, is the new one, is it added, stuff like that. Retcon fuses these 2 together. So like it reviews the whole both pieces of text and like compares them and merges some lines, inserts some lines, tries and get the order right. Gets the order right. Like there's a lot of It's not heuristics. It's like it's precise, but you have to figure out how to do that. And that was a mess. And what you get in the end is a single diff that you can present to the user. And even that is still there's still a small part of it. Because line numbers, for instance. So one of the things Retcon does is it tries to display just the info that's actually relevant. Like if you look at a commit, some clients might tell you about the message of the commit, good. The hash of the commit, useful, and the author, okay? And it will tell you about the committer, okay? Even if it's exactly the same as the author, not relevant, it's the same. And it'll tell you about the hash of the parents, okay? That's a little too much. Some clients even tell you about the hash of the tree of the commit, and I think 90% of people don't know what the tree of a commit is, and they're right. They don't have to know. This is really irrelevant information. And in the diff, to come back, sorry, I'm getting sidetracked. Really, is in the diff. Git will show you like these little at signs, like at sign, 13, 12, at sign. Same thing. Many people don't know what the numbers mean, and you don't really need them. They're really superfluous. There's a bit of interesting info in there, but barely any. So Retcon does away with all that. Boom, away. None of that. And with the line numbers, that's where we're getting to. Same thing. Old number, new number. Usually you know what neither of these mean. You're like, these are numbers. What can I use them for? What can I cross-reference them with? The answer often is nothing. You look in your editor and the same line has a completely different number. It's very strange. So Retcon only displays a single number, and it always matches what you see in your editor, which sounds like obvious. I mean, you ask anyone, if they do know about Git, they would tell you, oh, the line number is, well, that's the number of the line. They wouldn't think of anything different. But it turns out it's technically like a lot of work, because if you ask for different diffs, you'll have different line numbers. So when you have the stage diff, oftentimes, you have two numbers, and one of them, sometimes you don't even have the number you need, is what I'm getting at. So in the workdir diff, one of the numbers is the number of the right one. But in the stage, Retcon actually has to compute the number sometimes. So after it's assembled both diffs, it has to go through all the lines and infer the line numbers for some of the lines. Once again, like it's deterministic, like it's not a plausible heuristic or something, but it does have to, from context, compute the line numbers for lines in the stage mostly. If a line is in the stage under some circumstances, Git just doesn't tell you about this line number. And so I say, like I just told you about all of that, all these computations, all these things it does, and the result is, you look at Retcon, you look at the file, it's got 3 lines. You select line number 2, it says number 2. You stage it, and now it's checked. Nothing else has changed, and you think, hey, nothing else has changed. And that is so wrong. That is so untrue. Actually, like the diff is like the line comes from a completely different source, and the number 2 was previously given by Git, but now it's computed based on context. But visually, nothing has changed, and there was so much work to get to that space, to that spot where it's stable, like you would expect.
I appreciate this approach. So you've really done it on hard mode to make it feel like staged and unstaged are like kind of one point, and not have to think about that so much. But if you go into Git, CLI, and you're like Git status, then I'm assuming that you will see the actual stage and unstaged, which is a pretty hard thing to do, as you've been expressing. So before the show, we had talked about some other tools that I had my eye on. There's this tool called JJ or Jujitsu that's kind of a popular alternative CLI UX for Git. And one of its things that it does is it has a working copy as a commit. So basically any code that you have that's like in progress in your repo, it automatically adds that to a commit. It just like any changes you make are just amended to this sort of like work in progress commit. And so it simplifies this problem a little bit by just having like this like work in progress commit, like I was saying. And so it's not even thinking about like what stage or on stage. It's just automatically always committing things. The only problem is if you go in with like a regular Git CLI and you like look at the state of things, it's like, oh, well, there's nothing staged and I have this like weird commit, and now they have to do a lot of things in the background to, keep track of like, okay, what is the actual history? What are the things that you actually want to push versus, so there is some decisions that they will have to do that are sort of like different than the decisions you make. But I think what's interesting about your approach is you make it sort of like you cleanly preserve the actual Git working state, whereas they've come up with an alternative model that sort of like changes Git. Likewise, we had Scott on, who was one of the founders of GitHub, and he and his team are making this tool called Git Butler, and they have like virtual branches. So you can have like a lot of in progress stuff that is unstaged, but they like exist in different like virtual branches. Again, the problem here becomes this, like, if you do like Git status in the CLI, it's like, oh, you're on the Git Butler integration branch, and like anything that Git tells you at that point, the CLI is just like lies. So, it's like there's all these trade-offs. So I really appreciate the like hard work that you did to like keep the like normal Git working model sort of contained, I guess.
Right. So that's super interesting because one of the things I did consider for Retcon, one of the early sketches in my in the sketchbook, is I was like auto commits, and so the idea was like, yeah, creating commits takes too long. Like I'm a very impatient person, and creating commits takes too long. What if I didn't have to press the commit button? And that was the whole idea at that point. I mean, of that feature, like the commit is created as soon as you stage things. Like, why not? And when you stage more demands, then yeah, why not? And then, I thought about it, and be like, oh yeah, but that's gonna be confusing. And also, we like pressing the commit button. It's like it feels like confirming something. So anyway, I abandoned the idea, and I went on to the next crazy idea, which was, what if everything was staged by default? Like by default, you could still unstage, but it would be saved by default. And I really liked that idea because it removed the step of staging everything when you're interested in that. And then I realized, yeah, but that's gonna mess with everything. Like if you use any other tool in parallel with Retcon, it's gonna be a mess. And so yeah, I hadn't really thought about it. I haven't thought about this recently, but yeah, in Retcon I did a lot of work so that it would respect the existing state of things, the existing workflows you have, the other tools, the existing model. And so yeah, for the most part, it won't mess with these things. It won't crazily stage, unstage things, even create branches, technical branches. And you can totally use Retcon in concert with your command line, staging your command line and committing to Retcon the opposite, etc. For the most part, you won't notice crazy stuff happening. Retcon really tries to be like, removes its shoes at the door when it gets into the Japanese home. That's sort of this feeling you could get. Yeah. In some like I need to point out, like in some ways it doesn't do that. When you rebase in Redcon, like when you're on history, it doesn't use the interactive rebase system at all. Like you can't continue it in the terminal because it's a completely different way of doing things. And when it sets aside your current changes, like when you resolve the conflict, like your current working directory, it's preserved, but like it's preserved in Redcon memory mostly. So you won't be able. It's not a stash. That's what I'm saying. Like it's not an actual stash, but mostly it tries to respect your the environment, that environment.
Yeah, that's nice, and it allows you to like not have to build the whole world, because like most Git tools have to build everything from the start to be like a real contender to be a replacement in your workflow. Whereas this is like there's one part of Git that kind of sucks in all the other tools too. Its own tool makes a lot of sense.
That's a good point. And actually, that's doubly relevant here because that is something I was alluding to at the start. In Redcon, basically, every feature has to be built on the virtualization engine. Like for a rebase, I can't use Git's rebase because if you want to rebase while paused, Git will say no. There's a conflict. So Redcon has its own rebase logic, like that it can run there. And every single feature, even just displaying the current branch name, well, when you're rewriting history, the head is, it's a detached head. You've checked out. Sorry, when you're paused, you check out an old commit. And actually, this is what happens in the command line. Like it'll show you like the hash of the commit, which is not helpful at all. You don't care about that. You want to be like, oh, I'm rewriting main, so it still shows main. So in Retcon, in the branch list, it'll still show main because it's not showing you the physical head. It's showing you the virtualized head. And so every single feature of Retcon has to be sort of rebuilt. This is one of the things that slows me down. I have whatever I add, I can't use much of the original Git logic, or at least I have to build a wrapper around it to properly inform it of the actual state of things. So it is very useful for Retcon to respect your existing workflow, and as you say, that allows me to not have to re-implement the world.
So wrapping up here, we usually like to ask a future-facing question. And for you, I want to ask you, what do you think the future of source control looks like?
That's a good question. It's interesting because Git is there, right? Git is, everyone uses Git, not everyone, like game developers don't, but it's like the default. There's a monoculture of Git, and it's not a bad thing because Git is really good. Git is open source. Git continues on evolving. I don't know. Right now, it's hard to imagine anything replacing Git, but I guess that's always the case. Like you always have this one thing. It's hard to imagine anything replacing this, and then it gets replaced. I don't know. So far, the approach, also the thing that locks it in place is the ecosystem. I mean, we have GitHub, of course, but we have Git clients. There's one called Retcon. If you don't know, it's pretty cool. And all these things, they add value to Git. So it would be pretty hard to replace. If someone was to replace it, it would have to be really different. At the same time, I guess there's so much to be unhappy about with Git. For all the good it is, like Git is incredible, but also there's so much to be unhappy about. I guess that's possible. And when I started using Git, the first time I heard about Git, it was a colleague, and we were using SVN at work. But he was using an adapter. He used Git commands basically and Git concepts on top of SVN repo. Maybe something like that will happen on top of Git. Yeah, it's actually possible.
Yeah, it's fun to think of all the apps that might come of like what you're doing, where you're kind of building on top of Git and going the extra mile that they might not need to or want to.
Yeah.
Yeah, I could totally see Git just becoming the sort of infrastructure where the model is retained and the services are retained, but like what you're doing and like what a lot of other products are doing is like the UX just changes on top, and how we interface with Git just like fundamentally changes, but the things that are under the hood just kind of persist.
And we probably have a lot of examples of that in other areas like the web and stuff like that, where the core state as the compatibility layer, but then higher level abstractions are built on top. That would be cool to see.
Yeah, a set of good primitives gets you real far.
Yeah, for sure.
Indeed.
Cool. Well, that wraps it up for our questions for this episode. Thanks for coming on and talking about Retcon, Nathan. I'll definitely be using it when I want to reorder commits. So yeah, thanks for talking to us.
Thanks.
Yeah, thanks, Nathan. And, congrats on the launch. That's huge. The tool looks awesome. I'm excited to give it a try. And so for the listeners who want to give it a try, you can go to retcon.app. That's retcon.app. Cool. And thanks for joining us.